6:60 with Forever here on the Radio Wammo Breakfast. Time now, 16 minutes past 9. Let's get the latest in new science with Janine Young joining us in Melbourne City today from New Scientist magazine. Good morning, Janine.
Good morning, Wammo.
And first up today, we're talking moons, and I say moons because there's a possibility that the Earth has more than one moon. Is this right?
Yeah, it actually is. It's not going to be the large one that you just haven't spotted in the night sky that is, suddenly going to become visible. That's not quite what we're talking about here.
Okay.
What we're talking about is very, very small asteroids, chunks, if you like, of rock that are orbiting Earth, but they're so tiny, they're only meters across, that they're really, really hard to spot. They can be at distance up to 12 times that of the moon. They're part of Earth's gravitational field. So it means that they're tiny, but we can't see them. And realistically, we don't really know they're there. There's very likely one up there at the moment, and most people just haven't been able to spot it. And nobody really knows it's there.
But wouldn't we just normally call these things asteroids or, floating rocks? They're not really moons as such, are they? Really.
If something is in Earth's field and it stays there, it's not just, going to shoot off again, then it is a moon. That's what it is. That's the way the definition works.
Okay.
So these little things that pop out, because if they're travelling at roughly the same speed as Earth's Earth's spin, so they're able to fall into Earth's gravitational field, even if they're there for only 9 months, that still means that they're one of our moons because they're actually part of our gravitational field.
Wow.
So, yeah, as I said, it's not like one's going to pop up in the night sky and we suddenly go, ooh, I haven't seen that before.
Yeah.
But people are interested in these things for a number of reasons, not only because they are odd. Now, no one's really noticed them too many times before. There's only been one or two confirmed ones. In the last few years. There's one in 2006 that certainly was. But they could give us clues if we could get to them about how planets formed, because asteroids are left over from planet formation. And so you can look at the relative reason people are interested is because they're quite metal rich a lot of the time. Now, there's three types of asteroids. You've got the M type, which is really, really metal rich. You've got the S type, which is more stony, but that's very rich in iron, nickel, magnesium. So again, quite helpful. And then you've got the C type, which is the most common. They're the ones that don't have as much stuff. They've got the standard sorts of things that you would see in planet formation and the like, except for the hydrogen and the helium gases. But they're still very, very valuable on Earth because of these precious metals. William Hartmann in 1994 did an analysis of what a 2 kilometre wide asteroid would be worth in 1994 dollars. I'll point this out to bring it back to Earth and to be able to extract what's inside it. He said that value was $25 trillion. So that was in 1994. They think it'd be worth about $87.2 trillion now. To put that in perspective, the US deficit is 15.5 trillion.
Wow.
So there'd still be some spare change to do some useful things with it.
Wow. Okay, cool. All right, well, that's really interesting. On to something completely different. The possibility in the future of being able to download a pharmaceutical drug or something and then just print it at home, which seems rather extraordinary.
This sounds a bit weird,
yeah.
And it's not quite possible for us to do yet. But researchers at the University of Glasgow have been working at ways to use a $2,000 3D printer. These printers are becoming a lot more common now. It's something that you're seeing through a lot of different industries. It could be jewellery making, aerospace, dental, medical. It's being already used in a number of different industries. What they did was develop software that was able to talk to the printer. What they did was printed their own chemical reaction chambers. Then the printer squirted in the reagents for that chemical reaction and were able to produce chemicals out the other end and the appropriate configurations in the way it was meant to be done. They've been able to add a catalyst into the inside of the reacting chamber And they foresee, in, not next week, but in time, that what people might be able to do is go to a chemical app store, if you like, download the appropriate software and instructions that they need for their printer, somehow buy the reagents. Quite how you do that's not clear at this point. And then suddenly you can maybe make ibuprofen, which is fairly useful. That'd be nice, wouldn't it? Just to be able to go, well, I don't have time to go to the shops.
Yeah.
Let's just print
it off. Yeah.
An interesting idea, not quite there yet, but the idea of being able to potentially be able to do this in the developing world is very appealing, because a lot of the time they need drugs now, and they potentially need drugs that large pharmaceutical companies aren't making. So there's a possibility that you could make much more niche products for people who really need them now. It's an interesting idea.
Yeah, fascinating concept. Well, those you'll find in the New Scientist magazine coming out, or the next New Scientist magazine, also newscientist.com. Janine Young, thanks very much for joining us.